Exercise 4a, question 8. So we have to do the series expansion of h of x up to and including the x squared term. You can see I've underlined that. Always worth underlining key parts of questions, I think. So let's start by just working with the algebra first of all to work out what we need to do expansions on. This is 6 marks. So it's going to take a fair chunk of work. So I've got 1 plus 5x. If I moved it up, it becomes to the power minus 1. And I have 4 lots of 1 minus 3x to the power minus 1. Okay, so there's 2 binomial expansions to do here. I'm going to do them on separate lines, clearly identified. So let's start with this one. I'm not going to times by 6 yet. I'm going to put that in afterwards to make life easier. So I'm going to show the marker if this was an exam question. It's worth always treating your work as an exam question in layout because it gets you into a good habit. So I've said I'm going to expand that. My x is 5x, my n is minus 1. So that's 1 plus minus 1 nx, so that's my nx, plus n minus 1 minus 2, n minus 1 over 2, 5x squared. So if we write that up, I've got 1 minus 5x. I've got the 2's cancelled, 2 minuses make a positive. I have 25x squared. Okay, so let's work on the second one. 1 minus 3x to the minus 1. My x in this case is minus 3x, and my n again is minus 1, so that should be a reasonably straightforward. So that's 1 plus minus 1 lots of minus 3x. So that's my nx again using my brackets. I've got minus 1 minus 2 over 2 minus 3x squared. So I've got 1 plus 3x plus, so again, I've got 4 minuses make a plus. I've got 9x squared. That minus 1 minus 2 over 2 cancels out to leave 1. Okay, so now I have those 2 terms. I'm now going to go back to my function. And as they gave it in letter form, I'm going to use that to make it like easier. And I said that was 6 lots of the red expansion. So that's 1. Give me a second, just get rid of that. It's better. I've got 1 plus, sorry, 1 minus, and again, scribbling stuff out, it is nicer if you can get rid of it. 1 minus 5x plus 25x squared, and I've got minus 4 lots of my second expansion, which was 1 plus 3x, make it clear, plus 9x squared. So if we work it out, that is 6 take 4, so that's 2. I've got minus 30x plus, no, minus 12, so that's minus 42x, and I have 6 lots of 125, which is 150, minus 36, so that is 114x squared. And again, the line above is enough work. I've clearly shown how I'm using my expansions. It is, of course, oh no, it wasn't to show that. So I've got my expansion and I'm now going to have to use it. So it says, find the percentage error in using the series expansion by A to estimate the value of h is 0.0, so 0.01 to 2 sig fig. So first things first, h of 0.01 would be my function 6 over 1 plus 5 lots of 0.01 minus 4 lots of 1 minus 3 lots of 0.01, which equals, and a calculator will give it you exactly for this one. The calc button on your ClassWiz is quite good, over 679. I'm just going to double check that one. Pretty sure that's right. Double check it. 679. Yep, that's right. Sorry, my handwriting on my notes there. Okay, so if I put the 0.01 into the expansion, that's 2 minus 42 lots of 0.01. Just give my computer a second. It's having a slight hiccup. That writing should appear. There we go. Always makes me laugh when it does that. What was it? Plus 114 lots of 0.01 squared, which is 1.5914. So percentage error is my 1.5914 minus my 108. And I'm going to keep that exact as I know it exactly. I did check, by the way, what it was. It was 1.590574. So I knew I was in the right ballpark. Okay, times 100. So that is the predicted minus the actual divided by the actual. Okay, so if I stick that in my calculator, I get 0.052%. Quick check on the accuracy. It did want two significant figures, so remember that's those two. Any leading zeros are just placeholders. Okay, so I've got my percentage error, and the question then is a thinking question for the last mark. Why is it not valid? Well, you need to think about what your validity is. So first things first, I did an expansion with a 5x and a minus 3x. And I'm actually going to do this a little bit longer than I might normally do because it's a good opportunity to look into validity. So for the first expansion, that was the modulus of 5x is less than 1, which leads to the modulus of x is less than a fifth. But for the second expansion that I used, that's the modulus of 3x. Remember, ignoring the sign because I'm going into a modulus, is less than a third. Ooh, quick recovery there. Now, I used both expansions in my question, which means both validities must hold true. Now, if x is less than a fifth, that is also true in the x is less than a third. All values less than a fifth are less than a third. But if I look at x is less than a third, that's not true, does not match less than a fifth. There are ones that match the green that don't match the blue, which means that my overall expansion, because it needs both, is using the strictest of those two is less than a fifth. So what the markers are looking for in this question is that fact. Now it asked why you weren't valid to put in 0.5. Okay, so we want to sort of say 0.5 is not, or the modulus of 0.5 is not less than a fifth. Okay, 0.5 is too high. Okay, so it does not match the validity. So it's just some sort of nice sentence there for that one.